Good morning, grade 10s. I hope you're ready to feast your eyes on this beautiful landscape and hot air balloon while we cover the very last sort of SOHCAHTOA principle before moving on to some revision and then trigonometric graphs. Let's imagine that you are sitting here in the sunshine of this beautiful field, basking in the afternoon sunset. And you are looking up at your friend in the hot air balloon. Because you have to elevate your head, you have to look up, you form an angle of elevation between the hot air balloon and the ground. So that angle over there, which I'm calling theta now, can also be called the angle of elevation. And this this horizontal line on the ground is a line that is formed in what we call the horizontal plane. Think about horizon, the word horizon, there the sun sets over the horizon. Flat lines that lie on the ground are called horizontal lines. And so an angle of elevation, if we were to make a right angle triangle from this picture, the angle of elevation is formed between the horizontal plane and the hypotenuse of that triangle. Right, now imagine your friend, the lucky one, up in the hot air balloon with that spectacular view. If he or she is looking outwards directly straight and they're not tilting their neck, they would be looking in this direction, right? Also on a horizontal line. But if they were to glance down and wave at you, the angle through which their head depresses or bends down would be called the angle of depression. So if you are looking down, D for down, D for depression, then you are creating an angle of depression. Now the very cool thing about this is if you two are looking at each other, then the angle of elevation and the angle of depression are actually alternate angles, and so they are the same size. Now, if you were given certain pieces of information and you were asked to find the sizes of these angles of elevation or depression, or even possibly to find the distance between you and your friend, or the height of the hot air balloon above the ground, all sorts of questions can be asked, but we can cope with that because we can just form right angle triangles and use those in conjunction with our alternate angles, as well as our very beautiful golden rule of SOHCAHTOA. So all this information on this page is pretty much all you need to know before you are able to tackle any question involving an angle of elevation and depression. So let's try it out in this example. Another beautiful hot air balloon image just to make you miss the outdoors and make you dream about what you're going to do once this lousy lockdown ends. Right, the angle of elevation of a hot air balloon is 76 degrees from a point A on the horizontal plane. So remember, the horizontal plane is anything on the ground. In this case, it will be a horizontal line stretched along the water. The point B, which is directly below the hot air balloon, lies in the same horizontal plane as A. So basically we're going to have a distance AB along the water here. The distance between A and B is 800 meters. Calculate the height of the balloon above B. Right, let's sketch the situation. Right angle triangles so that we can use SOHCAHTOA. And A on the left, B on the right. Let's call the height of the hot air balloon point C. And then fill in the 800 meters that was given to us. Now let's look at the question again. They are asking us to calculate the height of the balloon. Now a height will always be a vertical distance. And so we are looking to find the distance of CB here. But because we're dealing with a vertical distance and because of our knowledge of shade your rear, because x-rays tan your exterior, we should remember that vertical distances are generally represented by the letter Y. So I'm going to replace my little question mark with the letter Y. Of course, I'm going to fill in the other piece of information that was given to me, and that is the degree, the size of the angle of elevation of the balloon from point A is 76 degrees. Now let's see what we can do in order to find y. What is the relationship or the position of y in relation to the angle 76? Do you see that it's clear as daylight, the opposite side, right? What about the other piece of information that's been given to us? It's certainly not the hypotenuse of the triangle, which is AC. So the length AB must be the adjacent side. And an adjacent side, or a horizontal distance, is often referred to as x. So now let's do our two-tick method to see how we are going to apply SOHCAHTOA. Right, we have been given the opposite side. So I'm going to place a tick by the trig functions that have an O. I mean, that's what we haven't been given. We're looking for the opposite side. And we have been given the adjacent side. So I'm going to place a tick at each trig function that has an A for adjacent. The one with two ticks, it is TOA. So I am going to apply tan of 76 degrees is equal to TOA, or y over x, opposite over adjacent. Let's fill in that relevant information. So tan of 76 is y over 800. If you want to make y the subject of the formula, it's as easy as placing your finger over what you need, and there you see you end up with a tan 76 and an 800 at the bottom. So in order to get rid of a denominator, to undo dividing, we are going to multiply by 800. So y is equal to 800 times tan 76. Pop that in your calculator and you're going to see that y is 3,209. I've rounded off to the nearest meter. The answer is in fact a decimal. 3,209 meters above the ground. Now that is ridiculously high. I am not fortunate enough to have ever been in a hot air balloon, so you tell me if that is a completely ridiculous and unrealistic answer, or do hot air balloons actually get to be that high above the ground? I don't know. Go Google it. Anyway, that's that for the day. You are now required to answer a couple of questions on angles of elevation and depression, and if you fly through this exercise, then you may as well start on your revision exercise as well. So today is, let me work it out, today is Tuesday. Tomorrow you can work on your revision exercise, and then Thursday we're starting trig graphs. So this is the last little slideshow for the next couple of days. Enjoy the time to catch up, reinforce concepts, reach out to your teacher if you need to. Right, thank you, grade 10s.